now, so it's we have this is like our insert, one of our small insert molding presses, and we do we can do small items here where we're putting they're actually putting 4 pins, and then there's 2 threaded inserts that go in there. So we mold this part and unthread it. So they're we go from this size up to the larger, but it's all kind of insert mold, and that's what, like I said, on yours, I have a feeling it's going to end up a lot of insert molding to be able to get what you're wanting to do. These are like an ABS. For this job here, it's a spinning, it's a little bit flexible, a little bit, and it's a good material all around. For what you're doing, it's not good. I mean, it's not forgiving enough, I guess, or whatever. It's not gonna take the bounce and be able to hold on to it. Yeah, that one part I showed you that was flexible. Here's a larger version of it. This is a nylon. Okay, it's called the Super Tough, and this one when it's assembled, the whole idea behind it is you drop this on the ground and it bounces, and that it's a protector for so
can't break it.
That one material that I showed you for the handle, here's a Packard. It's a cap, as you can see. When you get a little thinner, it's pretty, but it has the snapping features on it, and it's pretty tough. I mean, that little part there, it's completely chemical resistant. It'll take pretty high heat, so you're up 400 or 500 degrees.
That was one of the ideas that I had, actually being able to just snap the top cap on. Whether that's a good idea or not, because I don't think that would be, unless there was an O-ring involved.
And that might be what you want to do. It just depends. Yeah, it's kind of just depends on how you want to deal with the stuff.
Right.
But that's kind of, we have, as you can see, we go this 15 is a 170 size. That's our largest press, which allows us to do 8-9 inches in parts. So like I said, yours would fit fine on that, and then we go down from there. Material-wise, like I said, it's just there's a whole series of different materials that we use. We also have our secondary operation.
That thing's pretty cool. Yeah.
So we have our secondary operation. We do a lot of either like heat staking, we do soldering. So we can do depending on what people need done. But like here, we're getting in power supplies. They're cutting the ends off because either somebody messed up in, or they messed up in China, and so they sent them over to us, and we're remolding them. So we put a new end on them.
Molded pin plug, huh?
What's that? Yeah.
Yeah.
So we can overmold those. And a lot of different materials. A lot of nylons. Like I said, we go from polypropylene, very soft. We actually use a lot of green blends of like in the polypropylene, we use a lot of reblends where it's been like video cases and DVD cases where they're reground, and we use that for some of our products. And we have this is called Enviroplast. It's a new polycarbonate that might even look into some of its properties. But it's this one is an all green. It's a recycled material, but it's the company. They don't just recycle it. I don't know exactly how they put it. They run it through the reactor again, so it becomes almost a new material. They take old material and turn it into new stuff.
Excellent.
But that's a clear polycarbonate. Yours, we probably.
What does that look like? What is a raw material actually?
You have to pull it out there.
Oh. Calajack.
These, then like that material, that Santoprene, that's your material that's the Santoprene is a rubber, so that's a TPE. We use that for a lot. That's automotive right there. So anything that connectors or anything like that would be, that's the kind of material we use.
I think all this is injection.
Yeah.
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 We used to use injection molding, injection metals also.
Oh, so it's just a little bead form.
It's like crystals.
Yeah, they're just a little pellet. When they go into our machine, it gets heated and then liquefied, and then it goes into the mold.
Huh.
So
That's just crystals, basically what it is, but plastic.
So, but again, like I said, so this material was old material, reground, reblend, or re-reacted.
Reconstituted or whatever.
Well, yeah, and it's kind of different than we have. Like I said, our other stuff, they kind of just grind it, remelt it, and repelletize it. This stuff here, it actually goes through a reactor somehow. This company actually takes used material from all over the world and reuses it, which is a great thing. And so they came up with the Enviroplast.
Enviroplast.
Enviroplastic. So we have, oh, you can just see it, that's fine. So it should have been anywhere. So anyway, like I said, we have lots of nylons, we have ABSs, we have polycarbonates, Rytons, they're all different, just different grades of material, so it's a matter of figuring out which grade, you know, the product. And like I said, I'll have to...
Really are ready for action around here, aren't you, Paul?
Yeah, keep busy. A lot of different customers, a lot of different items. So, yeah, like
Not like back in the old days.
no, there's so many you have to carry. Even like I said, like in the nylon families, you know, we have 33% glass filled in a black. There's a 30% in a gray. But it's a different, you know, a lot softer material. They need that one flexible for overhead lighting systems. There's the super tough, like that orange out there, and you know, or that little guy. They're kind of different ones. So they're all different ones. It's kind of neat. Yeah.
Well, I think you're our guy, Paul.
All right. Thank you.
Yeah.
So yeah.
Stays welcome to the club.
Oh, thank you. Yeah, well, it's good. Sounds like a pretty neat product you have. So it's just a matter of getting it out there.
Yeah, the demand is huge, and like I said, the first design, you know, was just to kind of get it, you know, out there and tested and things like that. And once the results, you know, prove that yes, this does burn the gasoline more completely and lowers the emissions significantly, then it's like, okay, let's redesign it and make it durable and long-lasting and low maintenance.
Right, we have one gal who's got a product that she started selling her prototypes heavily.
Yeah.
Not a good idea.
Right. Well, that's kind of the thing I ran into was that, you know, people started checking it out. Like, well, I want one, and I was like, okay, you know, and then you know, lots and lots and lots, and it's like, whoa, hey, wait a minute.
She can't get her new product designed because she's so busy building these crummy products. I mean, they're all hand built, and it's about ready to kill her. We're trying to tell her you have to somehow stop, and then take a breather and get the other ones built.
That's exactly where we're at right now.
She's not doing that. She can't focus on losing that little bit of money on the prototype, so she's spending more money than I think that she's making for what it costs.
That's where we're at right now. Is the space in between.
That's what we're going to do. We're not going to stop. That's what we're doing in the old lab.
Oh yeah. It's fine. It's when you start spending so much on if you keep the prototypes going and get more feedback, the better you are.